Bismillahirrahmanirrahim. Assalamualaikum. This is a video presentation of the CADD assignment number 3 and 4. In this assignment, some bioinformatic tools were used to describe the sequences and functions of two given protein sequences, DPMP113 and DPSP100. This video will show how the whole process was done. This is the sequence taken from DPMP file, DPMP113. BLAST is a tool to identify a query sequence and find similar sequences. First, open up the NCBI data website and then look for the BLAST tool. The BLAST page will open up. Since our sequence is a protein sequence, use the standard protein BLAST program. The protein BLAST page will open up. Now, enter the DPMP113 protein sequence inside the box. This can be done through copy and paste. Next, select the database non-redundant protein sequence, or NR for short. Then, select the algorithm. Choose the algorithm's position-specific related path, and then run the BLAST search. The results will come out, and the results will show the given conserved domains and the alignments of the protein sequence entered. When mouse over and click the red row, you will be directed to the alignment. There is a sequence ID at the top of the alignment. When clicked, it will give more information of the sequence. The protein sequence can also be identified using given database. Just like the previous way, enter the DPMP113 protein sequence. This time, select the Protein Data Bank protein, or PDB, as the database. The algorithm position is still the same, the SciBLAST. Run the BLAST search and the analysis will come out. The results will again give the conserved domain and the alignments, but this time it is the Protein Data Bank. From the Protein Data Bank. Again, at the top of the first alignment there is a sequence ID, which when clicked will direct to a page with more information of the interested protein sequence. The 4-digit of the sequence ID on top of the alignment is copied, and it will be used to search in the PDB database. The PDB is a database for the data of biological molecules such as proteins and nucleic acids. RCB is the biggest archive. Enter the 4-digit sequence ID. In this case, it is the sequence 4FGM, aminopeptidase and family protein Q5QTY1. Detailed information of the desired structure will come out. You can find the structure of the protein sequence. This is the tertiary or quaternary structure of the sequence. You can also find the secondary structure of F4GM from this protein database. HistoProScan is a program that can give the functional analysis of proteins by classifying them into families and domains. Open up the HistoProScan 4 website. At the space provided, enter the protein sequence DPMP113 and then click the search button and wait for the analysis of the results to come out. There will be a visual output of the results. When you mouse over to the first button, the button can be clicked and it will show the analysis of the predicted domains. This is the first domain and the related explanation. The second button, when clicked, will show the second domain. So this protein has 2 domains. The third button that can be clicked will show the family which the protein is classified into. This is the DBSP100 protein sequence. All the steps done using BLAST previously is also applied for this protein sequence. The results will also give the conserved domains and the alignments for non-redundant database, as well as the conserved domains and the alignments for protein data bank database. The 4-digit sequence ID, when searched in PDB, will give information of the secondary structure and the tertiary structure of the protein. Next, we proceed to Clustal, which is a multiple sequence alignment program. This is the BPMP file with many sequences, one of which is BPMP113. Using Clustal, we can perform multiple sequence and profile alignments of more than one sequence at the same time and at fast rate. First, open Clustal and load the sequences from the text file in FASTA format. Click on Alignment, and results will come out like this. Complete alignment is done, and the multiple sequence analysis is saved into two file types. One is .dnd and the other is .aln. The multiple sequence alignment can be seen by opening the .aln file. Mega is a tool for conducting automatic and manual sequence alignment. A phylogenetic tree of sequence can be made using Mega by opening the .dnd file. This is the BPSP file. All the steps done using Clustal and Mega previously is also applied for this protein sequence file. The results will also give the multiple sequence alignment and the phylogenetic tree alignment of the protein sequences.